Hello everyone, Fro here. Welcome to today's presentation. In today's presentation, we're going to look at an introduction to algorithms and pseudocode. As an agenda, we're going to look at what an algorithm is. We're also going to look at what is a pseudocode. We're going to look at both of those with examples as well. And more specifically, we're going to dive in deep to say why is a pseudocode useful. And then at the very end, we're going to look at some possibilities of where to go from here. Now, we're going to talk a lot about pseudocode as part of this. We know in the real world, people don't like pseudo stuff, right? Pseudo medicine, pseudo science, pseudo chemistry. People don't like that a lot. But when it comes to computer science and the field of problem solving, pseudocode is one of the most powerful tools you can have in your tool belt as a programmer. Whether you're an expert programmer or you're just looking to get into the field of programming, more often than not, pseudocode is that entry point. I remember in college, before I think about writing any program, even up to now, I always step back to say, all right, what is the pseudocode here? How is this going to work? All right, and you might be able to write a pseudocode even if you don't end up writing the program. So especially powerful for both programmers, and even if you're not looking to be a programmer, this will be a powerful tool to have under your tool belt. That said, we're going to dive in and look at some scenarios here. And today's scenario would be the alien scenario. I've been using the alien scenario in some of the presentations. So today's alien scenario, we'll have an alien and we have us here. So the alien is giving us a challenge. And the challenge from that alien is, can we write a program that allows a user to check whether a number is even or odd? So this is the alien giving us this challenge. Go forth and write a program that if somebody gives you a number, your program can check if that number is even or odd. All right. And if you've done any programming or taken any programming courses, this is something that should be very trivial to do, or at least an entry point to just learn programming. So how do we tackle this problem? How do we go forth and write a program like this to solve this problem from the alien? Now, there are many options that we can follow, right? Depending on what programming language. We can solve this problem in, say, Java as an example, and this is what we have on the screen. We can solve it in Python. All right, and this is what we have on the screen. PHP, we can have something like that on the screen. If you throw in JavaScript, if you throw in Go, Scala, any programming language you come up with, we can solve a problem like that. But the challenge is the alien is looking at us here, or we looking at the alien. For somebody who's never programmed before, would look at this and it's scary and intimidating to say the least. All right, so if you've never programmed before, maybe have no understanding of Java, but you want to still write that program or still be able to come up with a way to solve that problem in the way machines do, in the way computers do, just going forth to write a program like this could be scary for most people. So if this doesn't make sense to you, if you've never written a single program in your life before, what the pseudocode would do is it's going to give us a way to still be able to come up with a solution to that problem. Even if we don't write the actual code itself, we can still come up with a solution to that problem. So if you've never programmed before, hang in tight. We're going to see how to come up with a solution to that problem. Now, the next thing that we want to see here, or the two key concepts that are very powerful, especially in the computer world of problem solving, is algorithms and pseudocode. And we talked about this at the beginning. So what is an algorithm? How do we come up with algorithms? What are some of the algorithms that are out there? We're going to look at that very briefly at a very high level. And then we're going to look at the pseudocode, how we can write a pseudocode to solve the challenge from that alien. Right? So in computer world, in computer science, the main goal is problem solving. That's what computers are about, right? Solving problems. Now, the way we solve those problems is to leverage algorithms. So what then is an algorithm? We're going to take a look at that. Again, the alien scenario. The alien is going to define for us what an algorithm is. So an algorithm is a set of rules that must be followed when solving a particular problem. An algorithm is a set of rules that must be followed when solving a particular problem. So if we step back and think about the problem that we have, which is given a set of numbers, which is the input. If I give you a number or a set of numbers, can you apply any rule or method to that set of numbers and be able to tell me if that number is even or odd? This is the basic mechanics of an algorithms. A set of input, we apply a set of rules, and once we apply the set of rules, we get an output from that. Input, rules, and output. At the fundamental level, that's what an algorithm is. All right, so let's take a look at an algorithm in practice. I think what we saw is a little bit abstract. Input, rules, output. How can we take that and put it in practice to see a real world example where we can apply an algorithm to solve a problem? So if you've heard the term algorithm and you don't know what it is before, that's exactly what it is. A set of rules we can apply to solve any problem. We apply algorithms every day in our life. Sometimes we do it without knowing that we're actually applying an algorithm, but we're actually using it, and that's what computers do. So let's see this example of being able to apply a set of algorithms to respond to a party invitation. So most of us, a friend maybe invites you to a party, or your co-workers inviting you to a happy hour, or the family is thinking about going on a vacation, and we have to make that decision. Should we go or should we not go? And we need to respond, right? For most people, you might apply a set of algorithms and not really know that that's what's going on. So let's take a look at this example to see how the algorithm comes in handy here. So party response or algorithm. We have the alien inviting us to an alien party, all right? Making an alien party or just a human party. So that's the party invitation. So are you trying to decide whether you go to that party or not? You have to respond to this. All right. So you have to decide, do I go or not? And so the question that you might have at the back of your mind is, as part of the steps, as part of the rules for you to decide, is to say, all right, are there any girls that are going to be in that party, right? If you think about a guy, they might be curious about girls going there, or girls might be thinking about meeting their friends there. All right. So are there any girls that are going to be at that party? This might be one criteria. This might be one rule that we check to say, all right, are there any girls? Nope. If there are no girls, then you probably don't want to go based on the rules of this particular algorithm. All right. But what if there are girls? So there are really two options. We're doing a conditional check here, and that term will come in handy. So we're doing a check, a conditional check here. If it happens to be a no, we stop. We know that we're not going. Respond, done. All right, and that's the algorithm. If there are girls, then we can go forth and check. Will Amy, maybe Amy is some girl that you're kind of curious about whether they'll be at the party or not. Will Amy be at the party? Is Amy going? No, then we stop. All right, if Amy is not going, then not going. All right, so you're looking. We've kind of gone through two checks here. All right, and then what if Amy is going? Is Amy going? Then we might want to dig further. All right, do I have a right to go to this party? So nope. If you don't have a right, then you probably are not going to go. All right, if you have a right, then definitely going. So this is a series of steps or rules that we can follow, that given any party invitation or to this particular party, we can say, yes, I'm going, or no, I'm not going. And you can have a response. All right, so if you looked at what an algorithm is: input, set of rules, output. Now, given the input, which is a party invitation, anyone can apply these rules and decide whether they're going or not. All right, so at the fundamental level, this is what an algorithm is in practice. All right, computers do this all day long at the fundamental level. Now, let's take this a little bit further. We've seen a set of rules to solve a problem. That's what an algorithm is. One thing to note, and I'm going to leave this at the end, is algorithms usually can be deterministic. Deterministic meaning, given a fixed set of input, if I apply the same rules, I should have a deterministic set of output. I should have the same consistent set of output. All right. But that's not always the case with algorithms. It's a little bit advanced beyond the scope of these presentations. But there are algorithms that are non-deterministic, right? More statistical method kind of algorithms, where given a set of input, you might have different outputs based on, the same input. So those would be called non-deterministic. But for the very simple case, for the very simple scenario, given a set of rules, like we see here on the screen, very simple algorithms will be deterministic. So if I know that if I'm going with this algorithm, I know there will be girls at the party, and I know Amy is going, and I know I have a right, then I will be at that party. I'll be at the party. So that's deterministic. If I know my input and I know my rules, I know what the output will be. All right. So that will be deterministic algorithms. Okay. Now let's go into the next piece. How can we take this algorithm to the problem that was given to us by that alien? And that problem, if we remember, is to write a program. All right. The alien was asking us to write a program that allows users to check whether a number is even or odd. So this is the problem. Can we write an algorithm? Can we figure out an algorithm and then go ahead and write a program to solve this problem? So how can we figure out, how can we deduce the algorithm for this? Well, we might want to look at examples. If I have a number, how can I figure out, is this number even or odd? Is there any rule, is there any check I can do to any number that you give me to see if that number is even or odd? Let's walk through some examples. The first example here is, let's start with the number 3. Now, I have 3 mod 2 equals 1. And what mod is basically take 3 divided by 2 and the remainder of that. All right, so that's what the modular operator is. So 3 mod 2 equals 1. So it means that, 3 divided by 2, there is a 1, 3 mod 2, there's a remainder of 1. Okay, so that's interesting. But why will I do this? Let's try some more examples to see why this could be helpful for us to know if a number is even or odd. Let's try another number, 4, for example. 4 mod 2. So if you notice, what's the remainder of 4 divided by 2? Is 0. There's no remainder. That's interesting. So 3 mod 2 is 1. 4 mod 2 is 0. Okay. Is there anything more? Let's continue with another number. Let's try 5. 5 mod 2. Oh, that's 1. All right. So now we have 5 mod 2 is 1. So, if you divide 5 by 2, 1 remains. That's interesting. This is 1. This is 1. Why is that? Let's try one more. Okay. So 6 mod 2 equals 0. Oh, 1 0 1 0. Do we start seeing a pattern here? All right. So 6 mod 2 equals 0. Let's try one more. 7 mod 2 equals 1. That's interesting. 7 mod 2 equals 1. So we have 1 0 1 0 1. I'm sure 8 mod 2 will be 0. So we can see a pattern here. All right. We can see a pattern here that's repeating. It repeats. It's not almost repeating. It actually repeats. So 1 0 1 0 1 0. But what does this tell us about even or odd? If we check, we can see that, well, 3 mod 2 is 1. Whenever we have a 1, then that number is an odd number. Whenever we have a 0, then that number is an even number. So 5 mod that is 1 odd, 6 mod 2 even, 7 mod that is odd. And if you repeat, we can start seeing that whenever we have the number mod 2, if the remainder is 1, then it's an odd number. If the remainder is a 2, then we have an even number. If the remainder is a 0, we have an even number. That's a rule that we can apply. So given any number, right, 1000 mod 2 is what we know that's is 0. All right, I just know it because it's 1000, so that will be an even number. 999 mod 2, it ends with a 9. I know that would be a mod 1, of course, right? 2 doesn't divide 9, so that there'll be a remainder of 1 there, and that will be an odd number. So given any number, we can quickly just do this modular operation and figure out if that's even or odd. Now, what we're doing here is we're taking a problem that we have, and this is how programmers think. This is how people in computer science think. We take a problem, we figure out what the rule is, and generalize the rule. So we figure out by simply maybe looking at examples, a rule, and we can generalize that rule to wider scenarios. And then we can go ahead to write a program to solve this for any scenario that you give me. All right, so let's go ahead and write that program to take in any number and give us a result whether that number is even or odd. All right, and we're going to do that with a pseudocode. We're not actually going to write the program here itself. We're going to take advantage of the idea of a pseudocode. So if you've never programmed before, you should still be able to write a pseudocode given any problem. So let's get the definition of a pseudocode from our alien friend. So per the alien, a pseudocode is a step-by-step written outline of your code that can gradually transcribe into the programming language. All right, so a pseudocode, just to repeat, is a step-by-step written outline of your code, and this written can be in English. It doesn't need to be in any programming language. You can just write a pseudocode in plain English. You can just outline your code in plain English, and once you've outlined that code in plain English, it should be easy for anyone to translate it into any programming language. So all we need to do to write a pseudocode is to understand the problem, have an algorithm that we hope to use, and then write it in plain English. So if you can write plain English or plain French or plain whatever language you're familiar with, you can write a pseudocode to solve this problem. Most computer scientists who solve problems, usually they start with a pseudocode. So it's like an outline. If you're trying to write an essay for your literature class, teachers always recommend come up with an outline, come up with a structure for that essay to give you some guidance of what it is you're going to write. Because a structure, an outline, gives you some context to work with. And same thing with programming. Before anyone gets on the keyboard to write a single line of code, you should be able to come up with that outline for it, a pseudocode. Now, the granularity of the pseudocode might be different, just like the detail of an outline might be different for each person, but you still need an outline nonetheless. All right, that said, let's go into the example of actually writing a pseudocode for the algorithm that we saw. All right, if we remember, what we saw was given a particular number, we want to tell if that number is even or odd. And what we saw is 3 mod 2 is 1, that's odd. 4 mod 2 is 0, even. So we saw a pattern where if the remainder is 1, it's an odd number. If the remainder is 0, it's an even number. But we want to write this in a way, we want to explain this instead of just sending somebody this example. Let's actually write this out in a way that makes sense, in a way that the programmer can appreciate. Again, we're not writing the code, we want to write this algorithm as a pseudocode. All right, we're writing this as a pseudocode. So the pseudo in code is basically code that is not kind of real. It's just like pseudoscience, right? Science but not science. Pseudo medicine but not medicine, right? If that really is a good way to explain it. All right, so again, we remember an algorithm is a set of rules that must be followed when solving a particular problem. And we have a problem here. Given a number, can you tell me if that number is even or odd? So let's go ahead and write the pseudocode for this. So what's the very first thing that we need? All right, let's get a list of numbers. So let's write this down. So this is me now writing the pseudocode. So this is us writing the pseudocode. All right, so what's the first thing that we need? Get list of numbers. All right, because we want to get a list of numbers so that we can check whether each number in that list is even or odd. So let's get the list of numbers first thing. And I'm going to bold certain keywords in here, and I'll talk about why I did that at the end. So get list of numbers. Then what? All right, maybe we want to loop through each number in the list. So once we have a list of numbers, then let's loop through each number in the list. So we want to just go through each number in the list. All right, we can loop through each number, or we can iterate through each number. All right, so this is a pseudocode we're writing. Now, once we loop through each number in the list, then what do we do once we get each number? Like if the list had 10 numbers and we're going through, we pick the first number, what do we do with that? So let's figure out what to do with it. So for each number, for each current number, and let's just call each current number X that we see in the list that we see. All right, so for each current number X, so we have a list of numbers, and we're looping through each of that number for each current number that we see. So for each X in that list that we see, then what? All right, how do we know if that number is even or odd. We want to check if that number is even or odd. But now remember, we have a way of checking if a number is even or odd. We can simply do a mod operation on that number and then check the remainder. All right, so let's go ahead and specify that. So for each current number in the list that we see, now we want to check, right? Let's take that number, since we're calling it x here, and say x mod 2. All right, and then the result would be y, because we don't yet know what this y would be. All right, so let's just call it y. I'm just calling that y here as an example. So we have a number x, we don't know what it is. We mod it by 2, we have a result, we don't know what it is. All right, now this result that we know can either be a 1 or a 0, because this is what those examples here tell us. It can either be a 1 or a 0. So we need to check more specifically for this y to see. All right, let's check now. Let's check for this y and say check if this y is 0. All right, and don't mind the equals to here 0. This just simply means check if y equals 0. All right, so let's check if y equals 0. Now this is now making sense, because if y equals 0, if we have some number, whatever number it is, x, and we mod it by 2, and we put it in a placeholder called y, and then we come back and we check and we see that y is 0, we know. All right, we don't even need to know what that number is. We just know that whatever that number is, it has to be even, because it's 0. All right, we just know because the algorithm has told us that. Now what if we check that the number is 0 and we realize that no, it's not 0? Then we can check else. If it's not 0, else we can go back and check if that number y equals to 1. Because if it's not 0, else, and we check it's equals to 1, then we know it's odd. All right, we can then say, okay, this number is odd. We can do that for every number that we have in that list. Right, so for if you had 10 numbers in that list, we can go through this 10 times, and then when we're done, we can just stop our program. We can say, all right, I'm done. We're done with the program. All right, so this is a pseudocode. It's a little bit more detailed, but it's a pseudocode. This is not a particular programming language. This is just plain English. This is translating an algorithm to plain English. All right, this is not Java, this is not Python, this is not Scala or Go or any language, PHP. This is not any language. This is just writing and thinking in plain English, just writing the way we think. All right, and that's what pseudocode is. It helps us solve a problem before we start worrying about actually writing the code. All right, a lot of people sometimes maybe want to get into programming, and the more worried about, oh, I need to know Python, I need to know Java, I need to know Scala. But the bigger effort really should be on the problem solving side, because once you understand how to translate problems into solutions like this, for the most part, it doesn't matter whether we're thinking about Java or Scala or Python, the concepts will come across, the key concepts will come across. And that concept of, can we get a list of numbers? Can we loop through? Can we loop or iterate through each number in that list? All right. For each number, for once we see any number in that list, can we do a check on that number? Can we do some operation and then check the result of that operation? If that condition works, if the condition is what we expect, can we check another else condition? All right, and then can we end that program? And this is what the pseudocode is really about. For most problems out there, 99% of problems, you can start solving that problem by writing a pseudocode. 99% of problems out there can be written in the form of a pseudocode. Now, why is a pseudocode useful? Why is it recommended, especially for beginners? Once you've done programming after a while, you might not need to go ahead and write pseudocode. You can just go ahead and start solving your problems. All right, but for beginners, where you have to worry about the syntax of a particular language and then the actual solving of the problem, pseudocode become especially important. It's just like an amazing writer, who writes a lot of novels might not need to outline their novels. They can just start and just write and come up with a bestseller because they've had so much experience. But if you don't have that experience, then pseudocode is where to start. So what are some of the advantages of a pseudocode? It describes how the algorithm should work. Again, your pseudocode is not your algorithm. Your pseudocode simply describes your algorithm. So we need to have an algorithm in mind, and then we can describe that algorithm with a pseudocode in plain English. Anybody that understands English can pick this and get a sense of it. All right. Now, next thing, to explain computing process to the less technical, the idea of pseudocode tool usually is, you don't need to be technical to understand what a pseudocode is. You don't need to have any programming skill to be able to read this and make sense of what we're trying to do here with this pseudocode. Next thing, to design the code in a group setting. All right, so just design the code in a way that others can follow. There are many advantages, but these are just some of the few advantages of a pseudocode. Now, that said, what we just saw in the pseudocode can be translated, and we started with this slide at the beginning, can be translated into now more specific languages. The implementation of that pseudocode in Java might look like this, or in Python it might look like this. All right, but if you don't program and you don't write code, I would reckon that it's a lot easier to understand that pseudocode than it is to understand the implementation here in Java. And even beyond that, once you understand the pseudocode, now this can start making sense to us. All right, so here we're having an x, we're checking if that x mod that equals 0, and then we're returning a result this is even, and then else we're returning a result that this is odd. So the specific implementation in a particular language becomes very straightforward once we can speak to what we're trying to do in the form of a pseudocode. It's just powerful. It's really, really powerful, especially if you're just getting into programming, beginning programming. You need to start thinking in form of a pseudocode. Now, what are some of the key concepts that pseudocode exposes us to? And these are concepts that are global across programming languages. These are key programming concepts. Again, when we talk about programming, the focus usually is to learn a particular language, but I'm of the school of thought that focus, especially very early on, should be on understanding the concepts of problem solving. And those concepts transcend a specific programming language. They transcend a specific programming language. What are some of those concepts that we can talk about? Loops, conditioners, iterations, and more, right? So loops, how can we loop through a particular list of numbers? Give me a set of numbers, and I'm going to loop through that number and check each number, whether it's even or odd. That's loops. Now, the way you implement loops in Java or Python or Scala might be a little bit different how you actually write the code for it, but it doesn't change the fact that it's still a loop. Right. Same thing with the conditioner. The way you check if one number equals to another number, or if one number is greater than another number, might be different in C# versus C++. There might be some differences in the syntax of the way you do it, but it's still a conditioner. All right. Same thing with iteration and more. So there are those fundamental concepts within programming that can be captured in the form of a pseudocode to help us communicate more, to help us problem solve, without getting bogged down into the nuances and the syntax and the nitty-gritty of specific languages. Now, since we talked about algorithms, there are many kind of algorithms out there. All right, when somebody's trying to solve a problem, you can make up your own algorithm, like we saw of the example of the invitation to a party algorithm. You can just make up your own, but especially in computer science, there is a whole library of algorithms that you can just borrow from without having to reinvent the wheel. All right, and this is for a completely different videos to dive into algorithms. There are deterministic algorithms, there are non-deterministic. Some of the ones that you might see are just simple recursion, backtracking, divide and conquer algorithms, greedy, brute force, randomize. Just so many algorithms out there. So depending on the problem you're trying to solve, all right, let's say you have a list of friends, and this is what Facebook probably did many years back on their platform, where you have a bunch of friends and they're trying to recommend a new friend to you. Now, how does Facebook figure out who to recommend to you? Or Netflix. Netflix had their recommendation engine of where, based on what you watch, they want to recommend other shows to you. How do they know that? They use an algorithm for it. right? They use a recommendation engine, which behind is powered by an algorithm. How does that algorithm work? So how exactly can Netflix know what movie to recommend to you? Or how exactly can Amazon know what products to buy? If you go on Amazon and you're buying, and they'll show you, oh, you might also like this. How do they know? They apply algorithms for that. Or Google search, that's one of the biggest algorithms out there that there is, right? If you go to Google and you go on the Google search bar and you type your stuff, in minutes or seconds you're having millions and millions of results. How can Google go out to query all the entire world's data to give you the best result that fits you? All right, how does Google know that? How does it know to rank items based on their relevance? They leverage an algorithm, and that kind of goes into search algorithms, right? So there are many kind of algorithms out there, and now even you might hear of machine learning algorithms, right? AI. Those as a whole area on its own, with a bunch of algorithms that are helping machines being able to look at an image and say, all right, is this image a cat or a dog? All right, and it applies a set of algorithms, some of which are supervised learning, some are non-supervised, and then you might start hearing about deep learning algorithms, right? Forward propagation, back propagation. Now the whole kind of worms opens, but at the core of it, when we talk about computer science, is problem solving. At the core of computer science is problem solving, and at the core of problem solving is this idea of algorithms. All right, that's what computers do. They're just applying algorithms, and there are a whole library of algorithms, and if you understand how to take those algorithms and apply them, the best way to understand that is through pseudocode, especially for beginners. And that's what we've covered in this video today. So thank you for joining. I hope this was helpful. So just to recap, we saw what an algorithm is. We saw what a pseudocode is with examples, how to write a pseudocode, how to think in form of a pseudocode. We saw why pseudocodes are useful and why it's important, especially as beginners to programming, to start with pseudocode, to focus on pseudocode for problem solving. Computer science is all about problem solving, and you can solve problems with pseudocode without being bogged down with a specific syntax the specific syntax or semantics of a language. And once you know that, you can easily translate your pseudocode into whatever language it is you want to translate to. And the possibilities are limitless. You can take this and apply to any problem you're trying to solve out there. Pseudocode algorithms is the way to go. Thanks everyone for joining. Thanks for watching. I hope this was helpful. Introductions to algorithms and pseudocode. Please consider liking this video. Share it with somebody that might get value out of it. If you have any questions, don't hesitate to leave that in the comment section below. I'll be more than happy to respond. Thanks for watching again through here, and I'll see you in the next video.